This podcast is going to be the first one of the new semester, and the topic for this podcast is forces. We're going to begin this new semester learning about physics. We've been learning about chemistry for the whole fall semester, and now we're starting physics. And the first topic that we study for the spring semester is forces. Now, these notes are going to go in your brand new spiral notebook, in your new interactive notebook, and they need to go on page 9. It's going to be the first right side page that we actually write notes on. The other pages we're going to fill up with other things, but anyway, that's where you're going to write these notes, and I want you to set it up Cornell style like usual. I think you're going to find that as we study physics in this semester that you're going to have a very easy time of it, because you're going to find out that physics is really all about things that you're very familiar with, and all we're going to be doing is attaching some new vocabulary to all of the things that you experience in your everyday life. So you can see here a magnet on the left, and the magnet is an example of one type of force that we're going to talk about, and that's magnetic force. And on the right, you see the man lifting the weights, which I'm sure most of you are familiar with. And this is an example of a different type of force that we're going to talk about, and he's actually pulling on the weights. And a pull is a type of force. So our definition of a force, what is a force, is it is a push or a pull. A push or a pull. Very simple definition. So in this truck on the left, the man is pushing on the truck, and in this cartoon on the right, he is pulling on the rope. So that's all we're talking about here. A force is a push or a pull, and we're going to find out that anytime a force is applied, that usually there's some kind of a change that happens. Oftentimes it's a change in motion, so something's going to start moving or stop moving when there's a force applied. Now we're going to talk about two types of forces. The first force we're going to talk about is a contact force. And these are forces that act on objects whenever they touch. So these are forces that can only happen if two objects are touching. There are weaker contact forces, like if you're playing the piano, you're hitting the keys, or if you're playing the saxophone or something, you're touching the keys, and you're pushing on something, but it's not moving a whole lot, and you're not applying a whole lot of strength to it. There are other contact forces that can be stronger, like swinging a baseball bat and hitting a ball. You're applying a lot more force in that case most of the time, if you're a slugger, if you can really hit that ball over the fence. There are some other examples. Earthquakes cause so much force, they're so strong that over time they can actually build mountains, and I'm sure you learned about that when you took Earth and Space Science, how mountains are built by these earthquake forces. This picture on the bottom left here is a picture of actually Anchorage, Alaska. This is the 1964 earthquake that happened in Anchorage, Alaska. And one of the reasons why I like to show this photo is because this is one street, and you can see that here, let me see if I can indicate that. Here is where the street used to be, and before the earthquake, and you can see in the distance along here, that's one street. And then after the earthquake, there was such a shift in I think this earthquake lasted 3 minutes. So in 3 minutes' time, after the earthquake, the other side of the street is, as you can see over here, it's dropped. I think it looks like about maybe 10 feet or 12 feet. Quite a lot of force in this case. The picture on the right is a picture of the earthquake that happened in, 1989. 1989 in San Francisco. And this picture is amazing because this is a 3-story building right here. The other 2 stories were crushed in the earthquake. So you can see there's quite a lot of force involved sometimes with contact forces. So what contact forces do you think are shown here? Well, we have the Winter Olympics coming up, and this fellow is able to slow himself down as he comes down the mountain by turning his skis, which increases something called friction, which is a contact force. And this woman is pushing her shopping cart, so that's a push. So if you got those, good for you. Okay, let's spend a minute now talking a little bit about friction. Friction is a contact force, and it is a force that always resists motion of any objects when they're touching. So it's always going to either stop motion, if something's already moving, it's going to stop them from moving, or it's going to prevent something from starting moving. So it's what makes things hard to push. It's what slows you down if you're going fast. Sometimes that's a good thing, sometimes it's a bad thing, so think about that. Without friction, we wouldn't be able to walk because our feet are able to grip the ground, and it's the friction that keeps us gripping so that we can push off and take a step. If it weren't for friction, it would be like ice all the time. You know, ice has very, very little friction, and imagine trying to walk on the ice. I don't know if you've ever been to areas where there's a lot of ice, but it's very difficult, and you end up falling and looking like an idiot. But that's why friction sometimes is good and sometimes it's bad. When you're trying to go fast in a car, the friction is what uses up all that gasoline because, of course, it's trying to keep you from moving. But friction is a contact force, and it happens because objects, even the smoothest objects, still have a little bit of texture, rough texture to them, and it's the texture of the surface it's like it's gripping like Velcro. Now, the smoother the surface, the less you have those ridges and bumps that give it that texture that makes it stick together. And something that's very rough has a lot of friction, and it's going to have more texture to cause the gripping that causes the friction. So you can see here a bobsled. I kind of cut it off, but there's a bobsled. There's a lot less friction there, and that's why they can get going so fast. Same thing with these sled dogs. They can go real fast on the ice because there's very, very little friction. Now, friction depends on two factors, and that is how hard the surfaces push together and the types of surfaces involved. So we already talked about how rough the texture is, and if it's more rough, there's more friction. If it's smoother, there's less friction. But also how hard they push together, and you can think about, well, what would make something push harder? And what's going to make it push harder is if it is heavier. And that's why, of course, it's more difficult to push a heavier object because it's pressing down, so there's more friction. Kind of makes sense. Now, there are 4 types of friction. I only list 3 here, but there are 4 types of friction. The main one that I want you to be familiar with is fluid friction. But let's go back and talk about static friction. Static friction is the friction of objects that are sitting still, and it's the friction that holds them still while you're trying to make them move, or something's trying to make them move. It prevents things from beginning to move. Sliding friction is the friction that opposes motion when objects are sliding across each other, and it's what makes things eventually stop if they're moving. So you can think about pushing a box or something, maybe a box with just a couple of things in it. You push the box and it slides across the floor. Eventually it stops sliding. It's not going to slide forever, and that is due to sliding friction. And then let's talk a little bit about fluid friction. Fluid friction acts whenever a solid object is moving through a fluid. So that would include any objects moving through the air, like an airplane or a glider, or I can't think of anything else. But it also includes objects moving through water. So boats, any kind of boat or submarine, they're going to experience fluid friction. You might have also heard it called drag or air resistance. These are all names for the same thing, fluid friction. And then the 4th type of friction that I didn't put on here is rolling friction. And rolling friction is the friction on a wheel. And rolling friction is always less than sliding friction. And that's why we put wheels on things, because it makes it easier to push things. You have less friction. Okay, next I want to talk a little bit about non-contact forces. And these are forces that act when objects are not touching. They still provide a push or a pull on something, even though the objects are not actually touching each other. So an example here is magnetism. Magnets act without actually touching one another. They can push or they can pull without actually there being touching. And of course, we use that to our advantage. There are vehicles that move by magnets, some kind of trains, and we can levitate things. There's all kinds of things we're doing with magnets. Electricity is another one that can act without touching. If you've ever been shocked by a doorknob, that's because electricity moved from your finger to the doorknob and caused a shock. You could feel it. The other example, of course, is gravity. Gravity is a super important and very strong force that holds all objects in orbit in the universe. Planets around suns and suns in orbit in the galaxy around some kind of massive object at the center of the galaxies. But, I forgot what I was going to say. But one thing you need to know is that we think of planets having gravity, but really all objects have gravity, no matter their size. Just bigger objects have more gravity. So here's a little bit more about gravity. We think of gravity as Earth's attractive force, which makes things fall down, and we'll talk quite a bit in class about that. Once you get these notes written down, we'll talk about how gravity makes things fall down, and that's what we think of when we think of gravity, but really all objects with mass, any objects that have mass have gravity. It's a very tiny amount if it's something that's small with a small mass. It is measurable, though, and we can measure it. What we notice most, though, are the massive, massive objects, like the sun, and even the moon, and the earth itself. All right, last but not least, I do want you to understand the factors that affect the force of gravity. We talked about factors that affect friction. Now let's talk about the non-contact force of gravity, and talk about the factors that affect that. The first is mass. The bigger the mass, the bigger the force. Okay, so if mass increases, gravity increases, and that's why very, very massive objects have more gravity. The other thing that affects it is the distance. If there's a great distance, there's a smaller gravitational force. So as distance increases, the force of gravity decreases. And that's why as you exit Earth's atmosphere, you experience less and less gravitational force until they say you escape Earth's gravity. You don't really escape it because it's still holding you, but it's just the force is so small you can sort of fly away. If you're in a spaceship, you can fly away. But that's why, even though there are very, very massive stars out there and even black holes, we don't really experience much effect from those because they're too far away. We do, however, experience the effect of gravity from the sun, and that's because the Earth is orbiting the sun. The reason is because it's close enough. Even though it's very, very far away, it's still close enough because the sun is so massive, it does still pull on the Earth. And the same with the moon. The moon is fairly small by comparison, but it's very close comparatively, and so then you end up having some effect of gravity. Of course, we've talked before in class about the tides. The tides are affected by the moon's gravity. All right, that's a bit about it for these notes. Remember, these go on page 9 in your notebook, and I'm very pleased if you chose this option instead of the comic or just the PowerPoint, because I think you learn a little more by hearing me talk about it. So thank you to those of you who listened all the way to the end, and we'll see you later.
Made with Doodlecast Pro.